Hello once again, our most valued student. My name is Confident and welcome to part 2 of mathematics grade 9 paper 2. So this is part 2 and we have already done part 1. So if you guys are joining us for the first time, this is a Gauteng paper and we are revising November 2022 paper 2. We have already done a few questions here where we did section A. You can see that this is multiple choice. We have done that, and we did also question 1, 2, 3 up to question 5, and then this is where everything starts now. Section B, these are structured questions, and we have done question 2 and we went on 2.1 and I think we ended up here 2.2. yes, okay, so we are continuing with 2.3. so guys, grab hold of the previous video so that you can be able to understand. So we are continuing here, question 2.3. so this is what we're given. They didn't explain much, but there is something key that you need to always understand. When they give you a diagram, you need to analyze it first. Look at this. If I look at these lines, I like to make them bigger, but I think you can see from your side. You see this line, it says that, and then that is FG, and this line which is what? This line which is JM. When you are seeing that, it means they are parallel to each other. Are you with me? They are parallel, and whenever you are given these parallel lines, it always means a lot. We will see how we are going to use them to answer everything here. Now 2.3.1, it says calculate with reasons the size of P3, 2 marks. Let's go for P3. There is our P3 here. I think you can see from the diagram. There is our P3. We need to calculate the size of what? Of P3 giving reasons, and they made it what? They made it 2 marks. So what do you think with P3? Alright, I'm gonna use something different and something thicker. If you look at P3, there are 2 options. We can go for this P3, we can go for that, we can go for that, we can go for this. Are you with me? So that can in a way give us a triangle. Now in this triangle, I can find P1 if I want first, so that I can have 35 P1, then I can find that. So let's start by finding P1. Now P1, again, if you notice, P1 is in a straight line. You see P1? There is a straight line. And then if I look at this straight line, you see? So what is the sum of angles in a straight line? It's 180. So what we can have, remember here you're going with statement. You can say angle P1 plus 110 degrees is equal to 180. So what are you gonna say? This is angles in a straight line. They add up to 180. So you take that 110 to join 180. What do you have? We've got P1 is equal to 180 minus 110. Then you can get your answer. This will be equal to 70 degrees. So you've got your P1 as 70 degrees. Are you with me? And then lastly, if you take now, as I told you, let's take it back to say this was a like this. So if I add 35 plus 70 plus P3, these are sum of angles in a triangle. I must get what? 180. So if I can say P3, okay, let me use this. Now if I say P3, angle P3 plus the 70 degrees plus, remember sum of angles in a triangle, plus 35. Are you seeing that? I'm using that triangle. It must give me what? 180 degrees. These are sum of angles in a triangle. Are you getting that? So you take now 35, you take now 70 to the other side, then it gives us angle B3. So what will be angle B3? It will be equal to, you take a calculator now, you subtract. So it will be 180 minus 70 minus 35. Are you seeing that? Equal to 75. So it is 180 minus 70 minus 35, which is 75 degrees. So that is the answer. That was one way of getting this, to say this was 75 degrees. Are you with me? Remember the reasonings? Always give reasoning after the statement. That was one way. There are also different ways you could have, let me see, another way that we could have solved this one. It was, if we use, it's 2 marks, I think. Maybe there was a shorter way. Let me just check here. Alright, if you do this, that, and that. Okay. I'm just checking so that I can see if ever there was a simpler way that you could have used. Yeah, there are different ways. I just don't want to confuse you here. Now, let's just use, for example, this one. I think I've got it. Look at this. I think this was the most simpler way. I got it now. Look, I'm going to take this triangle. I'm going to make it red. So I'm going to take this triangle out, this one. Look at this, look at this, and look at that. I'm going to take that triangle out. Are you with me? So let me not put it there, but put it here. To say there was this, and there was this. This was the simple one. And then here, you do that, it's 110. Alright, and then you've got your B. And then this is our 3. That's our 3 there. And then you've got your K. And then this is your 35. This was the simpler one. Now there is the part which says here the exterior angle. Remember, this is a triangle. So this is your P. It says this angle, 110, is equal to the sum of these two triangles when you add. So what does it say? It says B3. If you take B3 and then you take K, we'll call it K1 because it's like K1 there, is equal to, let's call it P2 because there is P1, P2. And then what's the reason? Is exterior angle of a triangle. The exterior angle of a triangle is equal to the sum of the opposite interior angles. Meaning, if I take B3, which I want to find, plus 35, it must give me what? 110. That is the best way you could have done it. Then you take 35 to the other side. And then you've got your B3 here is equal to 110 minus 35. And then when you do that, what is 110 minus 35? Let's just check that. 110 minus 35. Then you get that 75. So there are different approaches here. Let's just use 2 and not get too far. Let me not get too carried away. So you could have used any of these. For 2 marks, I think this was the most preferred, the second one. But guess what? There is nothing wrong with doing the first one, using this triangle and sum of angles in a triangle. So now 2.3.2, hence calculate with reasons the size of what? B5. 2 marks again. Let's identify B5. I think I need to erase a little bit here so that we can identify. There is B5. See that? You see B5? Now they say hence calculate with reasons the size of what? Of B5. So now let's again identify what is it that we have with B5. Let's not forget our line here, this red line. It's very important. Now let me erase this working here. I hope you appreciated it. So because I just want to show you a few things there. If then with B5 we can take this. Remember these are parallel lines. Look at this. if I take for B5, there is this line which is AE. This is your A, this is your E, this is our E. And then I take my parallel lines, which are, I'm interested longer this side, which is that, and which is that. You see these parallel lines? Okay, let's take this off. So these parallel lines, don't forget, I have to do this, I have to do that. You must know something. Now the 5 is here. You must know that this angle, now, and what? This angle, they are what? They are equal. Do you know that? This angle and this angle, they are equal. Now you remember the F. Let me bring in the F. You have got the F like this. This is what you are having, is the F. And when you are having your F, this angle, where do I go? I go down again, and that angle are equal. What do you call them? You call them corresponding angles. Corresponding angles. They are equal. But at the same time, look at this. We have got this angle here. What is this angle? Is 110. This one is that. Remember? So now, first of all, you know what they call these two angles. We call them vertically opposite angles. So we know that this is also 110. So that's where we start. So what is that? We come here, let me erase a little bit here. It's P4. So you find P4 first. And then you're going to say P4 is equal to what? Is equal to, it was supposed to be P2, but let's just write it 110. 110 degrees. What makes us say that? We write them vertically opposite angles. That's the reason. You need to give us a statement and write a reason. Then from there, you come back again and say, you are using now this correspondence to say B5, because this is B, we know that this is B. Alright, and this was P. So we say B5 is equal to what? Is equal to P4. You write that statement. B5 is equal to P4. And then what is the reason? Corresponding angles. And then when you say corresponding angles, you need to give us the lines that make it corresponding. Then that's where you write that F, G, and J, M. What are these lines? They are parallel. That's what makes us say they are corresponding. So we are going to say FG is parallel to JM. That's the next important statement. FG is parallel. This is the sign for parallel to what? To JM. Always remember, when you say corresponding angles, give us the pair of parallel lines. This statement here that I gave you, this one, it's NB. Very important. Tell us, yes, it's corresponding, but which parallel lines are you using? Because sometimes you find that there are more than one parallel lines. There are the parallel lines, the FG and the JM. Are you with me? Then from there, you can therefore say, therefore, B5 is equal to 110 degrees. Or you could have just said here, which is equal to 110 degrees. Alright, then we're done there. Let's move on. Prove with reasons that HL is parallel to KM. 3 marks. Prove with reasons. They gave you also that. Now, I like to work on this side. Let me clear this space. Let me clear the space. Look at this. They are saying we need to prove with reasons that what? HL. This one. Here. I need that space. This one here. Let's mark it. Let's make it thicker. HL. There it is. Okay, still the same. Let me use that. HL. This one. they are saying prove with reasons that HL is also parallel to what? To KM. There is KM. They're saying these two lines are parallel. You know, these two lines. Let's prove with reasons that these two lines are parallel. So now, what are we proving? That HL is parallel to KM. Are you with me? Now, we do the same thing. I can look at this. They are the two lines. Yes. Let's look at this. Let's take HL like this. There is our HL. It's a bit shorter, so I'm gonna make it like take it a bit down, and then I've got the line K, what? This one, KM now, and then I got this part, this line like this. Now pay attention. This one is my HL, this one is my KE. I mean KM, not KE, it's KM. Now, you remember we did find P1. Look at this. Now, which angle is equal to P1 if these two lines are parallel? Now, let me give you a hint. You have got F again. This is F in this case. This is your F like this. This is your F. It's similar to F like that. And then I'm asking you, if these two lines are parallel like this, if this, let me extend my F like that. That angle is equal to what? Is equal to that angle. And what is it called? We talked about it. Corresponding angles. Why? Because HL is parallel to KM. So in this case, this will be your HL. And this will be your KM. Do you see that? So which means the most common angle that is equal, it will be that angle. Are you seeing that? And that angle, remember, this is 2. And this angle is 70 degrees. And then what was P1? Let's go and identify P1. P1 was also 70 degrees. Remember, P1 is equal to 70 degrees. So do you see that it shows that these two lines are parallel? Why? Because 70 degrees is equal to 70 degrees. It means these lines are parallel. But how do you now write this statement? So you start by saying here, P1. Was it P1 or it's P1? Let's identify. Yes, P1. You can even recalculate P1. You can just say P1, angle P1 is equal to 180 minus 110, you know, and then you're going to say angles in a what? Straight line. You don't lose anything, which is equal to 70 degrees. You don't, or you can say P1 is equal to 70 degrees, and then you mention to say question. Sometimes it's allowed, and then you mention to say question 2.3.1. Here reasons, you say 2.3.1. that can be another reason there. All right, not here. Are you getting that? Then from there, what you're going to say, you're going to also say but you're going to say what can you say? L1 is equal to, because this is more like L1, you're going to say but L1 is equal to 70 degrees. But use the word but L1 is equal to 70 degrees, and then what is the reason there? It's given. You see? Therefore, P1 is equal to L1, which is equal to 70 degrees. You see? And then you can say, therefore, HL. And then you can actually therefore, or before you say therefore, you write what? Corresponding angles. and then you say edge, therefore here there are corresponding angles like this, and then you say therefore you conclude HL is parallel to KM. Are you seeing that? That's how this goes about. Guys, you need to revise, you need to go through these slowly so that you can grasp this. Okay, now let's go to question number 3. I don't think there is calculations, we're not going to spend much here. I like question 3. It says match the description of the 2D shape in question 3.1.1 to 3.1.5 with the name of one of the 2D shapes given below. Write the answer in the space next to the description. Alright, a four-sided shape with one pair of opposite sides parallel. Four-sided. How does it look like? A four-sided shape. Let me just work it here. I hope it will be clear. It's a four-sided shape like this. Okay, it's just four-sided. Okay, like this. Okay, let me make it like this, and then like this. Okay, but I want to make it different. Four-sided can be like this, can be like this, like this, can be like this. Yes, it can be like this. It's a four-sided also, because they are saying with one pair of opposite sides parallel. I want it to be clear there. And you can see what shape is this. This is a trapezium. So here it's actually a trapezium is a shape with one pair of opposite sides what? Parallel. That's the common thing. There is one pair, not two. It's four-sided, but it's one pair. Next one, a four-sided shape with four equal sides, equal diagonals that bisect each other perpendicularly at 4 right angles. Guys, this one looks definitely like you are talking about a square. This one, look at it. You see, there is something special with the square. These are the diagonals. They are saying four-sided shape with equal sides. So when they say equal sides, this side is equal to this side, equal to this, equal to this. The diagonals, there is the keyword. The diagonals, they bisect each other at right angles, perpendicularly, right? And 4 equal angles. You see, this is all of them. These are 90 degrees, all of them. So what is this? It's a square. Do we have that part which says square? Yes, there. It's a square. There is it. So this one is a square. Alright, but well, if I miss it, you guys correct that. A four-sided shape with perpendicular diagonals and 2 pairs of adjacent sides equal in length. It's a four-sided shape with perpendicular diagonals. Okay, so the diagonals are perpendicular and 2 pairs of adjacent sides equal. It's more like this. You know, you need to know this shape. It's more like we are dealing here with a kite like this. Trust me. With 2 pairs. So this is the 1 pair, 2 pairs, with 2 pairs of adjacent sides. These are adjacent sides. And then we are saying a four-sided shape with perpendicular diagonals. Look at this. If I do this, the diagonals here, they are perpendicular. So what is this? This is a kite. Do you see that? You just need to try to see how they're trying to confuse and bring in. You choose the best, you see. You could have said four-sided and then you say it's a rectangle. Here, let's say you say, no, this is a rectangle. But you see, with a rectangle, the diagonals are not perpendicular, you see. You don't have a perpendicular that. You can choose, you can draw different shapes. You'll see that they say a four-sided with perpendicular diagonals and 2 pairs. You see, the square doesn't fit. It's 2 pairs of diagonals, 2 pairs of sides that are adjacent, that are equal. It can only be a kite at that step. A 3-sided shape with equal angles. This one I don't think is difficult. There it is, 3-sided shape like this with equal angles. So remember, it says this angle is equal to that angle equal to that angle. What do you call that? You call this an equilateral triangle. There it is. Right. So here we call it the equilateral triangle. Alright. And then I think the last one. This is the last one. 3.145. A four-sided shape with equal diagonals. Okay? Equal diagonals that bisect each other, but the diagonals are not perpendicular. A four-sided shape with equal diagonals. Okay, equal diagonals, a four-sided shape. We can actually look for a rhombus. Let's try this one. Here, what about this? As a rhombus, a four-sided shape with equal diagonals. Now, there is the problem, you see. A rhombus, this is not equal to that. So this one, I will say no. And then what about a rectangle? Let's try a rectangle. A four-sided shape with equal diagonals. You see, with a rectangle, from here to here, they are equal. And then they say, but the diagonals are not perpendicular. Definitely. So this can be a rectangle. Is it there on our list? Let's just check. Yes, it's a rectangle. Is it a parallelogram? This, all these shapes are parallelograms. To say a square is a parallelogram, so this is a bit vague. A rectangle is a parallelogram. Trapezium is a parallelogram. Rhombus failed, you see. So that the best answer there was a rectangle. Are you with me? So let's move on to the next question, 3.2. Now, given below a triangle WAS, let's try to mark it WAS. There is a triangle. Okay, there it is. I don't want to make this video long, so soon I'll be cutting it, guys, so that it can be just enough. And then what do we have? And rectangle TA, I'll just have to mark it like this. T, mark it inside, A, and then mark it inside so that I don't, this. So this is what we are given. Alright. Prove with reasons that triangle WTE, prove with reasons that this triangle WTE, this one, let me make it a bit bigger. This triangle, let's make it inside W. Okay, I just want to make it a bit inside W. I don't want to close this red. W T E, I just want to maintain that red color. Prove that WTE is what? What is this sign? Similar. This is a similarity sign, not congruency. This is a similarity. You see? Similarity sign. Is similar to what? Triangle EDS. Let's take that triangle again. E, there it is. EDS. See, they want you to prove similarity there. Alright, how many marks? It's 4 marks, and you must be given reasons along. So, but I have to see, this is X here. Can I just erase a bit here so that we can see? And a bit there, this is 1, and a bit there, that is 2. So anything that is hindering there. What about S? Okay, it's fine. Look at this. Similarities, you have to choose, compare the sides. That's all that you're gonna be doing on the similarities. It's a matter of you comparing these two triangles. Are you with me? So the first one that we can do is how can we approach it? It says prove with reasons that triangle WTE is similar to triangle EDS. Triangle EDS. Alright, so let's try first of all what information we have. Look at this. The first one that I pick up, there is a right angle, there is a right angle. You see? So we can say T1, angle T1 is equal to angle D2, which is equal to 90 degrees. Okay, let me put it in the statement here. Angle T1 is equal to angle D2, which is equal to 90 degrees. What is the reason? This is given to us. You agree with me? This is given to us. Okay, so we've got a 90 degrees angle. What else can we take from here? And then the next part, let's look at this. You know, when you're dealing with a triangle, what is special with a triangle? You need to remember with a triangle, look at this, the sides, the opposite sides, remember they are parallel. That is a given. Are you with me? So now look at this now. If I give you this line here like this, I give you this line, which is my WS, and then I give you also this line, and I also give you this line, and then I tell you that this is my T and this is my A for some reason. Now look at this. Because of that, it's F. Look at the F angle here, the F angle. If I give you this F angle and I tell you that this is parallel to this, even here, this is parallel to this. So what do you know about the F angle? You know that in this case, if it was this angle, it is what? It is equal to that angle. We call them corresponding. So even here, look at this. S is equal to that one. Do you see that? So this is 1. There is E there. So we can now come and say S, angle S, is equal to angle E1. Right. And then what is the reason? Corresponding angles. And then you need to give us the pairs of those lines. That makes it corresponding there. TE is parallel to AS. Give us that. TE is parallel to AS. They need that reasoning. Okay, so far we have done, look at this. We have done two things here. We have said, okay, 90 degrees, and then we said this is equal to this. So if two pairs, that, and these are equal, now you can now conclude that this third one now, look at this, this third one, therefore this third one, if you calculate the third one and you calculate the third one, you find that also they are equal, and then you can say therefore here, therefore is it W only? Yes, angle W is equal to angle E2. What is it? Angles, remember, angles in a triangle, you know, so these are sum of angles in a triangle. And then you can conclude and say therefore triangle WTE is similar to triangle EDS. What did we use? We used the first one was the angle, the second one was the angle, the third one was the angle. So it's angle, angle, angle. Remember, they can be side, angle, side. They can be side, angle, angle. But this is the reasoning. Angle, angle, angle. Then it means these sides are similar. And then there is complete the proportion statement for triangle WTE and triangle EDS. Proportion statement. 4 over what is equal to x over what? Let's look at the proportion statement. It's 4. I need to erase also some things here. Here. So they are saying 4 divided by what is x divided by what? So 4 and x. So we can say 4 divided by y. So look, we are comparing here. you compare. Where there is the 4 is where there is the y. You see, that's this side. And then where there is the x, it's where there is the 3. You see that? So 4 over y here, we can write that because the 4 over y is equal to x over 3. You see that? That's what they wanted there. And then xy, what do? You cross multiply. You see this? You cross multiply, you cross multiply. So here we are saying, let me write it in big numbers, 4 over y is equal to x over 3. So what happens is, because of the equal sign, the 4 multiplies the 3, the x multiplies the y. So that's why they say xy is equal to what? 4 times 3, which is equal to 12. Are you with me? And then from there it says, hence use the proportion statement above to calculate the area of the triangle TADE. 1 mark. Proportion statement to find the area of the triangle. What's the area of the triangle? X times y. You see? Remember, length times width. So you have got area of the triangle x and y. So you can write here area of triangle. Area is equal to length times breadth, which is equal to x times y. Now, what is x times y? Which is equal to 12. Alright, so that is the area of the triangle. You just leave it like that. That's why it was just 1 mark into that. Alright, and then let's wrap it up here. We're gonna wrap it up here. 3.3. We're gonna end it up here. Question 3.3. We can follow. In the shape below, GAB is equal to that. KFD is equal to that. There it is. They give you these things. There is GAB. There is there is KFD. There is GFB, and then there is that. They just gave us that. Now the question here is, 6 marks. Okay. Determine with reasons the size of alpha. They are interested in this, my guy. All right. So how do we go about it? 6 marks. It means there is a little bit of working that one needs to do so that you can go to that. You can't just approach that alpha without doing a little bit of working. All right. This is what I want to do. I'm going to do this on alpha. I'm going to come up with my triangle like this, triangle like this, triangle like this, which will be K, A, and H. I'm going to use that to say this alpha. There are many ways. This is your alpha. I need to find that, and I need to find this. Are you with me? Then we can talk about sum of angles in a triangle. But to do that, I can start here. I can start with this line, sum of angles in a triangle, and find this one here. Are you with me? So KAH, that's the one I want to find. Let's start there to say KA, that angle AH, right, is equal to 180 degrees minus 117. I must separate it. Which is equal to what? Which is equal to what? 180 degrees minus 117. Remember, 180 degrees minus 117, which is equal to 63. What is the reason? Sum of angles in a triangle. Or angles, yeah, sum of angles in a triangle. So you know now already here it's what? It's 63, but I'll take it into my diagram here. It's almost there. We got the first one. Now I'm interested in which one? I'm interested in finding this one here. But to do that, you don't have to hurry. Don't be in a hurry. Don't be in a hurry. Now look at this. I'm going to take this triangle, use a different marker and make it thicker. Look at this triangle. It doesn't have to be complicated. Look at this triangle here. You see this? Now this angle 133 here is equal to this one plus this one. You add these two, the exterior angle equal to the sum of opposite interior angles. So we can use that. I can use that statement, and I'll write it like that to say, I'll make it to say the angle HF, that angle HFD is equal to angle G, is on its own there, plus angle GH, F. Right. Then now what you do is what? Exterior angle of triangle equals to interior opposite angles. Oh, you just say exterior angle of a triangle. I think that's the reason. Let's not say much. Exterior angle of a triangle. It's not like that. Exterior angle of a triangle. Then from there, what do? You've got 133 degrees is equal to G, which is 37. Are you getting that? Plus GHF. So what you do, I hope there is still enough space. Yes. You take 37 to the other side. So 133 minus 37 is equal to angle, because we want that, angle GHF. See that? So we use our calculator to say what is 133 minus 37. Then you get what? 96. So 96 degrees is equal to GHF. So we are still here. 96, we're here. And then you come back and say, remember, these are called vertically opposite angles. So this angle automatically becomes 96 degrees. So what is it? KHA. KHA. Then you say, therefore, KHA is equal to GHF, which is equal to 96 degrees. And then what is it? Vertically opposite angles. So I know now that here I've got what? I've got 96 degrees. There it is, my triangle scene. So if I add alpha plus 96 plus 63, what do I get? I get 180, sum of angles in a triangle. Or if I subtract these two from 180, I don't have to because of my space, then I'll say therefore alpha is equal to 180 degrees minus what? Minus these two angles, 96 and 63. Minus 96 degrees minus 63 degrees. Then what is it? Angles in a triangle. Or you can say sum of angles. Let's use the word sum. Sum of, even sum the right, interior angles of a triangle, just to be clear. Then what is your alpha? Your alpha then becomes 180 minus 96 minus 63, then becomes 21 degrees. Alright, there is your alpha. Okay, there were many different ways. We could have approached it. We could have actually here just I'm just thinking loud. We could have even did this to say this triangle here. Let me make it thicker. This triangle here, and this triangle here, and this triangle here. You see? Now we know that this angle, if you add them, you get 117. Remember, exterior angle is equal to sum of opposite. So in a way, you could have said 117 degrees is equal to alpha plus this K, H, A. You see that? So now KHA, you come back and first solve it like this. remember you have to find now the angle here. We have to find this one, and we find that it was what, 96, and then you say 117, because you know that this is 96, right? 117 is equal to alpha plus 96, and then take 96 to the other side. So 117 minus 96 is equal to alpha. That was another way. Then when you subtract 117 minus 96, you get what, 21, you see? So alpha, which is equal to 21 degrees. Different ways you could have done this. Trust me, there were many. There were actually different ways. Okay, now look, we're in question 4. Different question altogether. So definitely I need to stop here, because question 4 is different transformations. So guys, in the next session, we are looking at question number 4. We are looking at question number 5. Continuing question number 5. Continuing question number 5, 19 marks. You don't want to lose that. And then we end with question number 6. Join me in the next session. So I'm gonna cut this video here. Remember, this is the 24-minute lesson. Watch this video in 24 minutes. Don't sit in for hours trying to watch. Divide it into small 24 minutes pockets. Then it is going to give you enough time to absorb as much as you can. Give me some comments if you are benefiting. Don't just watch and spectate. Just talk to me. Talk to me so that I know there is someone on the other side of the channel. And remember, go to paper 1. I also did a video on paper 1 for the November 2022. Guys, I wish you all the best in your exams. We've come to the end of our lesson. Thank you.